All right, last one. We're now talking about a velocity versus time graph. Going back to this table, what does the slope of velocity versus time graph give us? It will give us the acceleration of our object. And then there's this thing called the signed area, and that is the space underneath the graph down to that x-axis in the center. And if we figure out that area, it gives us our displacement. So how far out of place an object is in a given amount of time. So when is this object first at rest? We know that unlike a position versus time graph where a flat line is at rest, we need to be not only flat but on the 0 line. So we can see that the first part of our line here from 0 all the way up to 2 seconds, our object is at rest. This would be a resting object. So what is the object doing from 2 to 5 seconds? From 2 to 5 seconds, it's on the negative side, so it's traveling in the negative direction. And because this line is getting further away from the 0, it is said to be speeding up. There are no curved lines on a velocity versus time graph, so this straight line would indicate that it is an object that is speeding up because it's traveling away from the 0 line. What is the velocity of the object at 10 seconds? All we have to do is figure out at 10 seconds where our line is, and we look over here, we can see that the velocity is 2 meters per second. That's a positive 2 meters per second since it's on the positive side. And what is the object's acceleration from 2 to 5 seconds? So from 2 to 5 seconds, so this right here, we need to figure out the slope of this line. So it's rise over run. So when you look at this object, we know that it goes 1, 2, 3. So -3 is its rise, and its run is 1, 2, 3 seconds. So the acceleration that this object is experiencing from 2 to 5 seconds is going to be -3 divided by 3, which is a -1 meters per second squared. Finally, we want to know what the displacement of the object is from 6 seconds. Excuse me. I intended to write 7. Sorry if I didn't set you up for success there, because 7 would be this point right here, all the way up to 12 seconds. So we're talking about this area right here. To figure that out, we need to figure out how many units it is on the horizontal axis and how many on the vertical. We see the vertical, it's only a matter of 2 meters. And then we see that we have a vertical, or sorry, horizontally we have 1, 2, 3, 4, 5. So if we're talking about displacement, 2 times 5 is going to give us a displacement of 10 meters. So in this time, this object would travel a total displacement of 10 meters.